Okay, morning everyone. Hope you can all hear me okay. This morning's webinar will be talking about sampling and making sure we're taking the right result, or maybe better described as getting a meaningful result. Okay. Okay, so my name's Tom Wharton. I'm Senior Consultant here at Latis Scientific. So I deal with a lot of the samples that come through and write reports based on the samples that you guys, the clients, send through. So hopefully I've got quite a good idea of the kind of thing that you guys are after today. Okay, so back to basics really. Taking samples, obviously everyone kind of knows what we're talking about there, but really it's making sure that we're taking samples based on what we're looking for. Obviously chemistry samples are going to be taken in a different fashion to microbiological sampling. Just there on the left, I'm sure everyone's seen that bottle before, but that's one of our micro sample bottles dosed with sodium thiosulfate. Dosed with sodium thiosulfate, which obviously gets rid of any biocides or oxidizing biocide that's in the system, so we can get a meaningful result. Obviously, a sample is just a snapshot of the system. It's never going to give you exactly what's going on in the entire system. It always depends on what time you're taking it, what time of year, temperatures, all kinds of different things. Obviously, the more we sample, the better idea we can get of a system as a whole, and build up a bit of a better idea about how our systems are coping and what's going on. Okay, so obviously, if we took lots and lots of samples, that would be great, but there is a cost factor in that. So it's about making sure that we take the right samples to get the right results, but do it as efficiently as possible. Okay, so there's plenty of guidance on sampling. Many of you will be familiar with things like HSG 274. Obviously, there's 3 parts to that now. Been in play for a little while. That's obviously the Legionnaire's disease, Legionella control in hot and cold water systems, as well as cooling systems and other risk systems. You've got the new HTM 0401. Part B is now split into 3 parts. A is design and commissioning. B is operational management, which is where we'll find the majority of the information on sampling. And obviously part C as well is Pseudomonas aeruginosa specific for augmented care. Now that's obviously for nosocomial, so hospital environments. A lot of the information there is similar to that in the HSG documents, but there is a little bit of additional information, and especially with regards to Pseudomonas aeruginosa, which isn't covered in obviously the HSG. BS 8552 is actually quite a good and prescriptive document with regards to sampling from hot and cold closed loop systems. So there's plenty of documentation out there. So there's plenty of guidance out there. We won't be going into too much detail of each of these today, but obviously if there are any specific questions at the end, then please feel free to ask. So we're just looking at a few things in terms of the case. Some questions need to be answered by a sampling plan, and it's important to have a sampling plan as we go in. So how many samples need to be taken to make sure they're representative? Obviously, if we use, for example, closed system sampling, a very large system is going to be requiring more samples to get an overall picture compared to smaller systems, and this is detailed in the documentation. So what parameters do we need to be testing? For example, you wouldn't be testing for molybdates and inhibitors, etc., in a domestic system. So making sure we're getting the right suite of tests. How many bottles of each sample are needed? Transportation we'll talk a little bit about as well, but obviously this is very important to make sure that the samples are arriving to the lab in the right time frames and in the right fashion in terms of temperature and transportation. How many samplers, how long they'll be needed for. This is quite important when it comes to things like Pseudomonas aeruginosa sampling, especially pre-flush sampling, where samples should be taken at no use or the lowest use possible, which can often be difficult if you've got a lot of samples to take. Okay. Okay, so most of the answers, most of the questions that need to be answered can be addressed carrying out a survey of the site. You obviously should ideally know what you want to take before you get to site, what there is on site, and the number of samples you want to be taking. Although it is always good to have an array of bottles if you can, just to make sure that if there are any samples that you weren't foreseeing, that you can take those as well. Obviously, optimal points to take samples from need to be selected. It's no good taking a whole array of samples from one supply tank, for example, in a building if there's multiple tanks. You want to get a good spread and idea of over the whole entire site. Any hazards, obviously, I mean, this is most pertinent when it comes to sampling from hot water systems, closed water systems, that kind of thing that are at high temperature. You want to make sure you've got the right equipment and safety, PPE, etc., to make sure that you're safe when you're taking these. Frequency that you're taking samples, and obviously transport, which we talked about before. Okay, so flushing of taps and outlets, etc., or even sample points is always going to be important. You need to make sure that you're taking the right kind of sample. For example, if you are looking at Pseudomonas aeruginosa sampling, just generic sampling, the HTM 0401 Part B does indicate that you should take that pre-flush, and then based on any results, then you look further into the sampling. So if you did find a positive Pseudomonas aeruginosa result, you'd then go on to the pre-flush and then post-flush sampling. The pre-flush will give you an idea of what's in that outlet or what's local to that outlet, whereas a post-flush sample, for example, running for 2 minutes or longer, will then give you an idea of what's in the system as a whole, so what's systemic. Obviously, the samples taken following flushing the sample point, more representative conditions of water flowing through the entire system. Okay, so we've got quite a few different types of bottle. Just that one on the left there is dissolved oxygen bottle. They also come in clear as well. I will say a little bit on dissolved oxygen sampling, as it often comes up. It's very difficult to get an accurate sample of dissolved oxygen in the system without making sure you carry out the correct procedures. For example, if you're taking dissolved oxygen from a closed system, you've got to make sure that you don't add additional oxygen. Obviously, as soon as you open up that system and there's a change in pressure and the water is coming in contact with atmospheric oxygen, you are potentially going to put that into the sample, and it will give you skewed results. So there is some quite extensive information in BS 8552 on that. And it's just making sure that you speak to the lab as well and make sure you've got the right fixing agents. The best thing to do if you're unsure of taking samples or what you need to be taking, if it's something slightly different, is just to give the lab a call and just discuss it with us to make sure you've got everything you need to take the right sample. So obviously you might need to arrange special access, etc. If there's anything that is more difficult to take, it's all very well in an ideal situation of having multiple sample points on systems, but certainly on older systems, for example, flow systems that don't really have many drain-off points or suitable binder points, etc., it can be difficult to find. Microbiological sampling, you want to make sure that you're obviously taking it in an aseptic technique. I think most people would probably understand that, but just to recap that quickly, is making sure that the bottle is sterile, obviously. When you open it, don't touch the lid or inside of the bottleneck or anything like that, or put the lid down on anything dirty, because you don't want to cross-contaminate the sample. Small sample container or even funnels, hoses can be used and necessary. Hoses especially can be useful when there's a system under pressure. Opening up a full bore quarter turn valve or a ball valve is going to potentially release quite a lot of water, and especially if it's at high temperature, that's going to be dangerous to the sampler. Especially also if you want to get pre-flush sample, you want to get whatever's in the actual run of pipe work that you're investigating. So a hose can often be useful in carrying this out as well. Obviously, a set of screwdrivers, spanners, etc., that kind of thing, invaluable to have on site. Four-way keys, gloves, goggles, all that kind of thing, are always a good thing just to have with you in your van or whatever you're using to get on site, just to make sure that you have everything in any eventuality. Okay, so sometimes you find yourself in a situation where you weren't expecting to take samples, and if you haven't got a backup supply in your car or your van, etc., sometimes you might have to make do. It's not ideal, obviously, but you can use sterile bottled water. Make sure you give it a good flush through. Chemistry samples really are the best option for this. You don't really want to be taking a sample from a bottle that you've been using all day to drink out of for a micro sample, as it's going to give you a skewed result. You can also use glass mineral water bottles, taking organics, that kind of thing. And there's also ways of making sure you can sterilize bottles, obviously by using antiseptic, and that kind of thing. Another set of items good to have is just sterile bags, alcohol wipes, sterilized scissors if you can, just so you can get samples from things like shower heads, something like that, and make sure you get the entire sample from there. So they're just a few options on there as well. Okay, so when we receive samples into the lab, it's often quite difficult to understand where they've come from. Sometimes we receive no paperwork at all, and we have to go hunting around for that and trying to find out who that is. Obviously, that's important as it impacts on the time in which samples can be plated up or analysed, especially if these are time dependent. Then that's going to potentially affect results, and you'll start getting deviations. So the best thing to do is to make sure that you're labelling up all bottles with as much information as possible. There is guidance on this throughout the water quality and also the Legionella sampling as well. We'll give you information on that. But really, you need to make sure you're putting as much information as possible, including where the sample's been taken from and in which manner. For example, closed system samples, we receive a lot of samples that just state LTHW or chilled water, something like that. And obviously, depending on what results you're looking for, or depending on the actual time in which you're taking it, in terms of a fit out, this is going to impact on the results and how they're interpreted. So, for example, you can't really use, or you shouldn't really use a binder point or pressure point to sample for total solids or suspended solids. It's not going to really give you an accurate result, and this is obviously going to impact, for example, on your validation results if you're pre-commission cleaning or you're just sampling after practical completion. So you want to make sure that you put as much information as possible so that we can interpret the results, and if we are right, report for you, just an independent report that we can give as much information as possible on that. Okay, so when you're sending in samples, ideally you want to be sending in samples, majority of samples stored at 2 to 8 degrees refrigerated. Obviously the exception is Legionella, which should really be transported at ambient temperatures around about 20 degrees, something like that. For the majority of samples, they need to be to the lab within 24 hours from the point of sampling. Legionella, you get a little bit of leeway, but the ideal way is still to get it to the lab as soon as possible. And this just obviously stops the amount of growth occurring in the bottle from affecting the results. We want to try and get a snapshot of exactly what was going on in the system at the time of sampling. Obviously, some samples, like LTHW samples, for example, aren't going to reach or might not reach that temperature by the time you get into the lab. Ideally, you'd want to transport or store while you're transporting chilled and LTHW samples or chilled and domestic samples separately, so that the LTHW samples don't bring the temperature up of all your samples there as well. Okay, is there any questions that anyone has? Okay, well, thanks for listening today. If you've got any questions, please feel free just to email them through. This will be going on YouTube as well, so if you'd like to go back and look into it in a little bit more detail, listen, and then make some questions from there, please feel free. And otherwise, thanks a lot, and hope to see you in the next webinar.